Hi friends, in this video we are going to learn the same problem we have discussed in our previous videos too. So here we are going to check whether we can reduce the error we are going to get by the approximation in calculators by using any other methods, by changing the format of the equation. So in the previous video we have changed that 1 minus 6x divided by tan squared x into minus 1 over 1 plus sec x, like that, so that we have cancelled out the error part. But here there is a part that if x is near to 1, we are going to get the part 0, the below part 0. So what will happen is the total part is going to become a huge number, so it might get an error. So how to solve that? So now we are going to take a look how to solve that. So normally what we will do is we will solve this equation as we know 1 plus x into 1 minus x. So we are going to get 1 minus x minus 1 plus x. So if we are write again 1 plus x into 1 minus x, so I'm going to get a minus x, so it's going to be minus 2x in the above part. So here the error type is increased because when the x is 0, x is very near to 0, we are going to get an error. Likewise, if the x is very near to 1, we are going to get an error when we are using approximation in those calculators. So how to reduce this? So that's the problem. So what we are going to do is, so if you want, plug some values like 0.00001 and check it off. So most probably you are going to get an error if you have an 4-digit chopping or 5-digit chopping for those figures. So what's the method we are going to use here? So it's a little bit complicated for the beginners. We are going to use the Taylor series to solve this. So how we can use the Taylor series? So 1 over 1 plus x. So here we are going to change this function for a polynomial function using the Taylor series. So let's write it like this. So let's say this is f of x. This is f of x. We are going to take only the first part. If I write it down, actually we knew the polynomial series of this f of x. Let's write it like Pn of x. The polynomial series using the Taylor series. So we can write it like this, which is going to be we are going to get an approximation. We are going to get near to 0. So x, let's say x1 is 0, or a. Let's say this is a. So the first part is going to be f of x into x minus a to the power 0 divided by 0 factorial. Likewise, if we write it down over here, we are going to get f dash x into x minus a to the power 1 divided by 1 factorial. Likewise, we are going to continue that, f double dash x into x minus a into 2 divided by 2 factorial. Likewise, you need to continue. So here we can write it like this, f of x, if I write directly, it's going to be 1 plus x. And actually we knew that x a is 0, so we are going to get x, 0 factorial is 1. Likewise, if I continue for this part, we are going to get, we need to differentiate this part, so f 1 over f dash of 1 plus x. So here we are going to get x, sorry, this is x to the power 0, which means we are going to get 1 and x divided by 1. So here we are going to double differentiate 1 divided by 1 plus x. Here x minus a squared, so it's going to be x squared, a 0, so 2 factorial, which means it's going to be 2 again. So please try it in your own. You are going to get, I'm not going to show the whole step, so if you simplify that, you are going to get 1 minus x plus x squared minus x to the power cube, x to the power 3 plus x to the power 4. Likewise, you are going to get the numbers. So likewise, now we are going to find the polynomial series or the Taylor series for the next part. So I hope you can pause the video and try it on your own. So now I'm going to use this polynomial function, Taylor series function, to figure it out what's the polynomial function we can write it off here for the f of x. So if I write it like this, using that formula, Taylor series formula, we are going to get 1 plus x squared plus x cubed like this. It's going to increase, power is going to increase. So actually now we have changed this to this format, 1 minus x plus x squared. It's going to continue. Likewise, if we change 1 minus x, 1 over 1 minus x into this part in the polynomial, we are going to get like this. So now what we can do is we can directly deduct this part from the original value. 1 over 1 plus x is this. So we are going to deduct this one from here. So if we deduct, we are going to get 1 over 1 plus x minus 1 minus x is equals to minus, we are going to get 2x plus 2x squared plus 2x to the power 4 plus 2x to the power 6. Likewise, we are going to get. So this is the answer. So if we use this equation, we can minimize the error. So sometimes you'll be getting a doubt. So what's the main thing, or what's the minimum number we can use to while we are getting a low error? So what's the minimum error? So what's the minimum relative error we are going to get, or what's the number for x we can use to get a minimum error? That's depend on your number. So you can choose any number. Let's say you are going to use like 0.001. So to find this, actually you need to plug it off for these two. Let's say you are going to use up to this value and see whether you are getting a correct answer. So after that, if we are not satisfied that, take another some more powers and do the calculation. Calculate this 0.4, for this 0.01, so that you can identify whether the error you are getting using these three is less. If this is less, it's enough to calculate. So you can choose for a finite number and use this equation. I hope you have clearly understood now that always you can change that format of any equation and reduce the error by approximate. Also, although you are approximating, you can reduce the error. So this is our final video regarding the approximation. So in our next video, we are going to start another new chapter. Thank you for watching.